Creation Fellowship. Oh, here we go. I'll start over. All right, good evening and thank you for joining us. Creation Fellowship in Santee has been meeting for 10 years in person and currently online. We're a group of people who come together to learn more about the 6-day creation account that happened some 6,000 years ago. You can find Creation Fellowship Santee on the internet at our social media outlets, Facebook, and sometime on Gab. We have 3 video platforms, YouTube, Rumble, and BitChute. If you go to www.tinyurl.com/CF Santee, SANTEE, you'll find where you can get us on the internet, or you can email us at creationfellowshipsantee@gmail.com, and you can email us if you want to get on our mailing list. And with that, tonight we have speaker Sal Cordova. He is a molecular biologist, and he is going to do his intro. So Sal, I'm turning it over to you.
Thank you. Glory and honor to our Lord and Savior, Jesus Christ, who created the world not too long ago and who will return soon. Let me share my screen. And it says here, you cannot start screen share while the other participant is sharing. I'm sorry about that. Let me try again.
No, go ahead. Yeah, it was, I was trying to get mine screen share off.
So let me introduce myself a little bit. To do that, I'm going to reflect on an event that happened April 28th, 2005. It was an event that changed the course of my life. That was the publication date of the prestigious scientific journal Nature, the April 28th, 2005 edition. On the cover of that, it said, "This journal contains material on evolution. Evolution by natural selection is a theory, not a fact. This material should be approached with an open mind, studied carefully, and critically considered." And the title of the cover story is Intelligent Design Coming to Your Campus? So this was almost kind of like a sarcastic comment. They were alarmed, scientists were alarmed that intelligent design is starting to matriculate into universities, not just the students, but among the faculty. This covered some incidences where faculty members were rejecting mainstream evolutionary theory. And in that article, it talked about George Mason University, and you'll recognize one of the students. It's a miracle of God and an answer to prayer. A young earth creationist was in the prestigious scientific journal Nature, the cover story. Amazingly, only like 6 months earlier, I'd said, God, who's going to pay attention to us, what we do here in this university? No one even knows us. And by a series of miracles, I ended up in this cover story talking about intelligent design. And I detail how I nearly lost my Christian faith. My dad was terminally ill, and I had accepted the Lord at a young age, and then I started to have doubts as I matriculated through science school, and I was like, God, why did my dad have to die? And so my faith was shaken, and I said, the only thing that can kind of keep me going is I understand science. I'm starting to have doubts about everything, including the Bible. And I said, God, I have some trust of science. And Jesus said in John 10:38, if you do not believe in me, believe the works. And little did I know at the time, I was actually following what Jesus said to do, study the works of God. And I began to investigate things very carefully. And I got restored to faith. I had a chance to share my restoration to faith there in a scientific journal. And I said, God, I think you have called me to do this. At the time, I was an engineer and scientist in the aerospace and defense industry. My dad died in 2003, April 27th, as a matter of fact, almost exactly 2 years before this article came out. For 18 years, I took care of my widowed and disabled mother. I quit my job as an engineer, and I believe the Lord led me to do that so I could care for my mother. And I also needed a job while working from home. And I said, how's this going to happen? And enter Dr. John Sanford. Dr. John Sanford is a famous geneticist. He was an atheist. He became a Christian and then a Christian creationist. At age 39, he became a Christian. By age 49, he was a young earth creationist. And let me highlight what he accomplished. He gave me a job where I could work from home. He said, Sal, just research whatever you feel led to. And I had the privilege of being mentored by him and serving him as a researcher. And that's led me to become a molecular biophysics researcher. I had, after that article in Nature, I had went on to Johns Hopkins to get a master's in applied physics at Johns Hopkins University. And then John Sanford, out of his own pocket, paid for my education at the FAS graduate school at the National Institutes of Health. I got a master's equivalent in biology too. And I had the privilege of working with him. And I'm going to cover a lot of his work tonight. Dr. Sanford is famous for inventing what is known as the gene gun. You could see the picture of the gene gun there on the left and other pictures of that. Through this, he improved the crop yields and fed starving billions. Yes, billions. The invention is at the Smithsonian National Museum of American History. This is someone with stellar credentials. He is a Cornell research professor, which is kind of an elite class of professors at an Ivy League school. So God raised up someone to help in the creationist cause from secular quarters. He actually came from secular quarters, and that is the picture of the gene gun that is at the Smithsonian National Museum of American History. It did make American history. And John said he felt that he owned the patents to this. He was able to retire early. And he said he felt God had appointed him to make this invention so that he had money to be able to finance creationist research. And he has devoted the remainder of his life proving that there is a creator and attacking evolutionary theory. He joins a number of other elite scientists in the secular world, some names you may not even know, but they're very accomplished, and they're also young earth creationists. He published in the Journal of Mathematical Biology. In fact, his accomplishment was so stellar that that article he wrote, and you have a piece of it right there with Bill Basner, set records in that scientific journal. And it was an article critical of evolutionary theory. It set records by a factor of like 4. And that was like in 2017. And that led to his co-author, the lead author, Bill Basner, being invited to biology conferences. And then Dr. Sanford was able to address the National Institutes of Health. Now, that was really incredible that they would, all these scientists, these evolutionary, pro-evolutionary guys, they would invite a young earth creationist there. But he had the credentials. He earned the right to be heard. And he talked about our genome crumbling. And that is the destiny of the human race, sadly. We need the Lord to return to fix this. So our genome tells us that we are intelligently designed, but also cursed and in need of a savior. And in 2021, Dr. Sanford and I published in the Handbook of Mathematics, a Springer Nature publication, by the way. It is now on university library shelves. It is critical of evolutionary biology, and I'll tell you how we got away with that. We only had to quote what evolutionists themselves have said about their own field. Now, the popular science writers will not cover it that way. They want to give a narrative like, this is solid science. But the evolutionary biologists themselves, in a moment of honesty, have at least enough integrity to say, this is a problem. They'll publish on it. Hardly anyone will notice, but it's there. My job was to help dig some of this up. We were joined by Bill Basner, who you saw earlier, and then Ola Hoster, who's an award-winning mathematician and professor of population genetics in Sweden. This was a stellar crew, and a miracle of God. We got this published. It is now sitting on university shelves. A little humor here. The book retails, you can buy it from the publisher for $1,500. You can get a copy at Walmart for $819. But don't buy it just for me, because I don't get a dime even if you buy it. It's the publisher that will get all the money for that. We get kind of the recognition for our contribution. And I'll cover a little bit of what we did in that. Now, as I said, all we had to do is just cover what evolutionary biologists themselves have said about their own field. And you have to think, this is a theory that has destroyed so many people's faith, but this is the state of affairs. Jerry Coyne, well-recognized evolutionary biologist, he authored the book, Why Evolution is True. He said, in science's pecking order, evolutionary biology lurks somewhere near the bottom, far closer to the pseudoscience of phrenology than to physics. And there's a reason that he's saying that. There are a lot of problems, even by their own admission. They don't need creationists to come along and point it out. They're starting to come to terms with the failure of their own theory, and it is painful for them. Now, the talk will cover this mathematical equation here, but I'm going to simplify it. This is just for those who are really, they're going to say, Sal, you're simplifying all this. Well, I am, for the sake of the audience, but our publication that's now on university shelves deals with this in all the gory details that you could see. That the simplified version I'm going to give today is going to be good enough. It's pretty close to understand why evolutionary theory is failing, particularly for human evolution. We don't have to go through all the gory math, but we had gone through this. This was agonizing, but we had to learn it. We had to understand it so that we could criticize evolutionary biologists on their own terms, beat them at their own game. And we found problems in their mathematical equations, and we've tried to correct it. And sometimes even their own data give us support without any correction. It's just been wonderful. So here are the words of an evolutionary biologist. This is what he says about the destiny of the human race. This is Michael Lynch, distinguished professor of evolutionary biology. He says, it remains difficult to escape the conclusion that numerous physical and psychological attributes are likely to slowly deteriorate in technologically advanced societies. The incidences of a variety of afflictions, including autism, male infertility, asthma, immune system disorders, diabetes, etc., already exhibit increases exceeding the expected rate. This observational work may substantially underestimate the mutational vulnerability of the world's most complex organ, the human brain. Because human function is governed by the expression of thousands of genes, the germline mutation rate to physiological disorders may be unusually high. At least 30% of individuals with autism spectrum disorders appear to acquire such behaviors by de novo mutation. It has been suggested that there has been a slow decline in intelligence in the United States and the United Kingdom over the past century. This echoes a lot of Christian doctrine if you're really thinking about it. God said we are created, but we are also cursed. And Jesus said this world is passing away. They're coming to terms with this, not just on the universal level, but even at the biological level. And they don't have answers because they're assuming evolution. And we get headlines like this in 2017. When I had started kind of looking at the creation evolution controversy, there is stuff now that is coming out in the scientific press that was not available to me 40 years ago when I was a young teenager. And now these headlines are there. Genomes are decaying. We're getting experimental evidence of this. And so how can this be? We're taught that Darwinian evolution says, survival of the fittest, so the best will survive and just keep improving indefinitely. That's actually not true when we examine things very carefully. So let's look, we have copy errors in our genome. We call those mutations. Most of those copy errors, the overwhelming majority, say 90 to 99.99%, we don't know the exact figure, would be actually compromising and damaging to the genome. It usually does not result in complex functional improvement. It may improve reproductive success, such as antibiotic resistance, if it's not involving what they call plasmid transfers, horizontal gene transfer, but it usually is a degrading of the genome that enables it to acquire new capabilities. And we can cover that in the question and answer. But let's hypothetically suppose we have a population here of healthy individuals represented by green and birth defected individuals represented by yellow. The theory of natural selection says survival of the fittest, keep the best, toss the rest. So I'm just gonna, let's just say 20% is defective, hypothetically, just for the sake of argument. And I'll have the terminator here destroy the defected mutants. Sayonara, muchacho. And it looks like, hey, look, Darwinian evolution works. The keep the best, toss the rest. There is a problem, however, that Darwin and a lot of evolutionary biologists haven't considered, except the few elite who really are thoughtful. What happens if all the kids have a slight birth defect that the parents didn't have? Well, what can you do then? You can't just eliminate everyone, that entire generation. So you might eliminate the actually worst of the defective, but they're all defective. So you keep some of the, you keep the best of the defective. It's still survival of the fittest. The fittest genome has actually passed away in the parent. And that is a scenario Darwin and all these evolutionary biologists in general did not consider. And I try to explain this to your typical evolutionary biologist, it flies over their head. The people that understand this are the elite class, the mathematicians, the mathematical evolutionists known as population geneticists. They have sensed this. Dr. Sanford, when he was still an atheist evolutionist, he remembered his professor saying, this is a problem. And they said, well, maybe there's going to be a solution. Well, there's no solution to it. He became a creationist. He followed through on what you're seeing here illustrated. So basically, the species survived, but each generation is dumber and sicker, just as Michael Lynch had pointed out. And there are more and more of these things coming out. The fundamental problem is if we're getting, say, 100 slight defects in our genome, or say 80 per individual per generation, then evolution is false. So there's this project, it's $1 billion project with its follow-ons called ENCODE. And their research was really kind of identifying how the genome worked. And as they studied this, they came out to the conclusion that a lot of the genome's a lot more functional than the evolutionary biologists had claimed. Evolutionary biologists said most of the genome is junk. And they said, well, our experimental results says it's functional. But that also implies that if you have that much function, it's just all that many more things that can go wrong. And therefore, it looks like we have possibly 80 to 100 slight birth defects per generation. It may be generally imperceptible, but just like tires being worn out as you drive them, the wear and tear starts to accumulate, and then suddenly your tires are no good. And it looks like that's the case for our genome. So an evolutionary biologist was not happy with the data. Again, this is a purely secular argument. This evolutionary biologist named Dan Grauer said, if ENCODE is right, then evolution is wrong. And he was livid. He said ENCODE has to be wrong because evolution is right. And he got it backward. ENCODE is right, evolution is wrong, and the genome is deteriorating. So let's see the effect of having 80 birth defects or mutations. Well, we call deleterious, but that's not, I prefer function compromising mutations, copy errors. As the children are reproduced by the parents, there are copy errors that the children will get that the parents didn't have, and it starts to accumulate. So let's just assume that we have a nice, clean, perfect genome, and the parent is represented there by where it has 0, which means it has no defective birth defects, whatever. That's the parent. And the parent, and there's some simplifications here that we don't need to get into. The parent has children. One child has 60 birth defects, the other 70, the other 80, the other 90, the other 100. And I say these are slight. You may not notice it in the kid. It's like you drive a car, you may not notice that the tread is actually worn a little bit. So these are slight enough that it would it would escape ordinary notice unless you're sequencing their genome. So let's do survival of the fittest, keep the rest, toss the rest. And okay, so the parent dies. That was the best genome in the whole family. So we're left with all the kids, and the worst kids, let's say, are eliminated by natural selection, survival of the fittest. Well, the fittest actually has defects that the parent didn't have. And let's just repeat the process. So this child goes on to be a parent himself, and he's just going to have, the next generation will inherit his defects, and then the next generation will also add to it. So even if we have survival of the fittest actually didn't survive because the fittest was the parent. It's the survival of the fittest among the siblings. And even if that holds true, the genome deteriorates. This again is, if ENCODE is right, then evolution is wrong. They themselves, the evolutionists, have set the terms for what will falsify their theory, and they are failing at it miserably. So let's fast forward to 1 million generations. It's going to be a disaster. This means, to me, looking at this, something specially created the human race not too long ago, and we could not have survived this level of deterioration. By the way, historically, how did the word junk DNA come up? They said one way to solve this is to, if most of the human genome isn't functional, that means there are less things that can go wrong, and problem solved. If we get up to one mutation, one defect per individual per generation, then the human genome is going to decline. We're at about 80. And so that's where junk DNA came about. Now, again, for anyone who's really anal about this, I'll explain a little bit of what this equation means. It means that kind of like what you saw with the average, like say the average mutation rate is like 80 or 100. You get some that are not quite 80, there'll be somewhat less. And we call that the Poisson distribution, and that's highlighted in red. And so the evolution will say, well, if you have enough kids, there'll be at least one kid that is free of these birth defects. Maybe mom and dad have to make a lot of kids, but maybe one of them is free of defects. And that's what this equation is trying to highlight. So how many would it take at the rate? And this is by an evolutionary biologist himself. If 80% of the genome is functional as trumpeted by ENCODE Project Consortium, then 45 to 82 deleterious mutations arise per generation. For the human population to maintain its current population size under these conditions, each of us should have on average 3 times 10 to the 19th to 5 times 10 to the 35th kids. This is clearly bonkers. I mean, this is how many kids a woman would have to have one kid that is free of birth defects. That's a calculation he did. That's not what creationists had to do. We've done that independently. I've done it myself. Dr. Sanford at the NIH quoted Dan Grauer's. Dan Grauer is saying, it has to be 10 to the 11th, 10 to the 35th. And that's bonkers. And the funny thing is, even if we use Dan Grauer's numbers, he's saying every female needs to make 44,000 offspring. Poor mom. So again, if ENCODE is right, then evolution is wrong. Evolution is therefore wrong. ENCODE is right. Experimentally, it's showing up. This is the reason ENCODE came to be. We're trying to solve things like cancer, heritable diseases, and how to treat it. And we're finding, we have to figure out that, how all this works. And we're finding a lot more functionality in the genome than evolutionary biologists are willing to admit. And Dan Grauer's reaction to this, he started calling the ENCODE scientists ignoramuses, crooks, the scientific equivalent of Saddam Hussein. He accused the director of the NIH back then, Francis Collins, of being a creationist. This has led to faculty, even at the same university, being at odds with each other, like these two. On the left is the evolutionist. On the right is the one who doesn't care. He's part of the ENCODE consortium. And then we get headlines like this. This is by Alexei Kondrashov. He was a colleague of my professor at the NIH. And if you see the thing underlined in red, it says, why have we not died 100 times over? Now, this is not a creationist saying that. This is an evolutionist saying, if you take everything we know, we should be dead. We shouldn't be alive. We shouldn't be evolving. And he had that rhetorical question. He came up with a solution that he thought would work. It has been since experimentally refuted. The problem remains, why have we not died 100 times or over? He also wrote the book, Crumbling Genome. And I just want to reflect again, Jesus said the world is passing away. Time is running out on us and the world is cursed. We're intelligently designed, but also cursed. We look at the patterns of biology, it agrees with Christian doctrine. There are others, also secular evolutionists like Brian Sykes at Oxford. He says the male population is just going to be gone, a future without men. I mean, these dire things are coming out. There are other scientists I could quote saying, we should be going extinct and we can't explain why we're around. Well, if we're willing to accept that we appeared on Earth relatively recently, according to a literal reading of Luke chapter 3, then the problem is solved. So this is typical evolutionary literature. I mean, look at all these people. These are major evolutionists. One of them there on the lower left-hand corner who actually began all this, Hermann Muller, won the Nobel Prize for his study of heritable diseases, what they call mutations, particularly the effect of radiation in causing birth defects. And then on the lower right-hand corner, if he didn't become a creationist, John Sanford would be considered an excellent secular geneticist and quite qualified to comment on this. So when I debate evolutionists, they try to say, oh, that's a creationist theory. I'm like, no, it is not. You're trying to pin that only on John Sanford. But look at all these secular scientists. And I got some funny looks when I confront an evolutionary biologist about that. I'd say, okay, can you name one researcher of this caliber that says the human genome is improving? And of course, I just hear basically silence. And that's, again, the question. Are there any respected scientists who think the human genome is improving naturally? Because if it's not, that means something else had to create the genome. And we also have experimental evidence to this effect on all biological organisms. Michael B. He published in a secular, mainstream, peer-reviewed publication and said most of these mutations are function compromising. That's very bad for Darwinian evolution for the reasons that I've highlighted. It also shows that you cannot accumulate complexity. You cannot evolve by natural selection naturally as Darwin envisioned. Intelligent design is therefore the best explanation for, in the opinion of many of us, but at the very least, without mentioning intelligent design, Behe just points out the experimental facts. We see damage. That's why if you take radiation and just expose a population to it, you're not going to expect that it's going to gain new capabilities. You'll be worried they're going to contract all sorts of, not just cancers, but all sorts of birth defects. It's not good. You accelerate mutation, it's usually bad. That's confirmed by experiment. And now that we add population genetics to this, there's no way that this is, at least for humans, there's no way it's going to evolve, from something simpler to where we are. We are dying. It indicates that we were miraculously created. We ought to be on our knees praying for God's mercy and waiting on the return of the Lord to give us healing. Our only hope is in him. And so Michael B. He published the book, Darwin Devolves. He covers that. So I'm at about 26 minutes, I think. And I'll cover just briefly why maybe mutations are generally bad. It's not been covered well. And I presented this at the Creation Research Society in July at Liberty University among my peers. So why do we get these things? Genomes decay despite sustained fitness gains. Fitness means reproductive ability. So like antibiotic resistance. So this is an example where bacteria are just developing a lot of capability to reproduce under a stressful environment where they kind of starved it. But they said, the genome's decaying. It's like, well, sometimes if you want to fly an airplane higher, You just kind of dump out all the equipment, make it light. It's pretty fragile, but you can get it to fly higher. Doesn't mean you've necessarily improved it. You're actually getting rid of stuff. And this is what we're finding a lot of times. Sometimes all that it's doing is just getting rid of stuff. It's, a last ditch, last resort effort. So, for the sake of argument, let's accept universal common ancestry. Just for the sake of argument, you all know I'm a young earth creationist. For the sake of argument, universal common ancestry. Does that mean even if all the individuals and organisms evolve from a single, like say, microbe, does that mean all the proteins evolve? Now, little joke here. That would also mean like this squirrel eating on the strawberry, he's eating a piece of his cousin because they're all related. Anyway, you can't extend that to the proteins. So the proteins are the things that are affected by changes in your DNA. So the DNA is a blueprint for the proteins. It gives the spelling of the DNA, gives, when it's translated, gives the spelling of the proteins. And the spelling of the proteins is very critical to its function. It creates all these geometric shapes, and geometry is priority. You could see that they're all different shapes. And therefore, even evolutionary biologists will say all of these proteins had independent origins. Now, they won't invoke miraculous special creation, but they're really close now. Unlike, they just say, well, I don't know. I'm like, well, this is going to be problematic if these proteins are complex. So I don't even get any argument over this creationist looking orchard, what we call the orchard model in creationism. There is one evolutionary biologist there. We had a frank discussion. I said, what do you think of my idea? He said, I think you're right. In so many words. I was in a debate with 55,000 people watching. There is this secular Satanist named Aaron Ra, and I showed that protein orchard to him, and he was like, he didn't know what to do with it. He wrote his buddies, came back to me later, and he thought he had me, and he said, there is no flipping common ancestor for all proteins. I used a family-friendly version of his quote to me. He wrote me this email, and I was thinking, dude, that's exactly what I said. And he was acting like I didn't know it. I'm just like, I'm the one who put it on the table. That's kind of I think it's kind of a sketchy rhetorical move. But he, who has been fighting creationists tooth and nail, had to admit there's no common ancestor for all major protein families. And why is this? And by the way, there are papers on this. It's kind of a simple reason. Geometry is priority. So we can kind of imagine how a car could evolve from like that first car by Carl Benz of Mercedes-Benz fame. And, the architecture today of the cars have, it looks very, it resembles the ancestor. And it's like, okay, I could see how this can evolve by gradual steps. But the problem is in the parts. You cannot take a part and say it's, the ancestor of like, say, a radiator, a battery, a spark plug, a piston, a tire, a gas tank. Can you think of a device that you can evolve in slow, gradual steps? And it's like, no, that's not going to happen. Okay, so maybe for an entire car, yes. But when you look at the parts, no common ancestor, it comes out of nowhere. And why would that be? Well, let me just, this looks, I call this, you see, this is a potassium ion channel. It resembles a nut, a man-made nut. And so I say that's God-made, and it looks kind of like the thing that's man-made. Isn't that cool? This has to be geometrically precise. That hole in the center, just like in the man-made case, has to be very precise in the God-made case. The geometry is priority. It cannot tolerate. It has to be that or it's dead. And geometry has a priority. People have heard the word irreducible complexity, all or nothing. If you don't have all the parts, this is from another presentation, so I'm sorry I'm having to blast through this. This is a protein that I have studied and worked with another young earth creationist who is a professor of biochemistry. He's an adjunct professor at Vanderbilt School of Medicine and also a associate professor at Freed-Hardeman and formerly Lipscomb University, Joe DeWeese. He's on one of David kind of a depiction, a Richardson ribbon representation of the topoisomerase. So there's Joe right there. He and I published in the Creationist journal, and he published in the prestigious scientific journal Nature. So he's also not only a great creationist scientist, but also a great secular scientist. This is the #1 science journal. I had the privilege of publishing with him in secular journals as well. And let me just show what topoisomerase does. And you could see why mutations have to be generally harmful.
Let's consider what happens as DNA unwinds during replication. As DNA unwinds, it acts like this rope when we pull apart its two strands. As you pull the strands apart, twisting tension builds up in the rest of the coiled portion. It is actually adding one twist to the remaining rope for each twist pulled out of it. At some point, you can't separate the strands anymore. The remaining rope is too tightly twisted. If you relax your tension on the rope, it will twist around itself in a supercoil. It is releasing tension. If you want to keep pulling the rope apart, you have to release the tension periodically, and one way to do this is to cut the rope and splice it back together. This problem has been best characterized in small circular DNAs. There are two methods of dealing with this problem in DNA. One cuts only one strand of the DNA double helix, and the other cuts both strands. Let's look at the first. Topoisomerase I enzymes cut a single strand of the double helix, pass the other strand through the cut, and reseal the break, relaxing the overwound molecule, which now has one fewer twist. Topoisomerase II enzymes do the same thing but with both strands of the double helix. Topoisomerase II cuts both strands of a double-stranded DNA and passes another double strand through the break and then reseals the break. So if a molecule of DNA is supercoiled, topoisomerase II can remove the supercoiling, 2 twists at a time, to yield a relaxed circle.
Now, the importance of this enzyme, it's a target of chemotherapy. If the genome is not untangled, the cell eventually dies. And so this is why it's a very well-studied enzyme. So chemotherapy, we try to just kill all the cancer cells. Sadly, we kill a lot of the healthy cells because we're trying to figure out how to get better targeted. But basically, if this enzyme doesn't do its job, we're dead. The cell's dead, and therefore we're dead. And so the question is, wow, this is really precise. Look at all the parts that have to work. It is, this enzyme resembles a pair of scissors, and it's not an accident. You have the geometry kind of like a pair of scissors. If the topoisomerase were to cut and it didn't have the ability to untangle and reconnect, it fails. It's all or nothing. All the parts have to be there. And, if it is able to untangle, but it doesn't cut, well, that fails too. So the one, if it cuts and doesn't do the other things, it's going to shred the genomes. All that has to be there all at once. And there has to be, just like these pair of scissors, there has to be a precise geometric connection for the parts to work right. Geometry is priority. And there are like 60 connections to implement the topoisomerase. And just like, and let me show you some further pictures here of that. So you have a nut and a bolt. Even something as simple as this that we take for granted, if they are not shaped just right, they're not going to be able to work together. It can't be too much or too little. So therefore, changes in the geometry, if you change the spelling in the DNA, it changes the shape of the protein, and it results in functional compromise. There's no way to really improve certain systems that are already optimized. Very hard to build something from scratch because you can't build it incrementally like the topoisomerase. It really has to be all functional. Otherwise, the system could be totally gone. And in worst cases, it's dead. And there are some things that are very technical here that actually natural selection works against the creation of complexity. And I'm working on some of that. And that is pretty much it. If I may share one last thing from Dr. Sanford, and I thank you all for your time. This is at the end of his book. He wrote at the end of his book, When I was young, I accepted the fact that I was going to die and that all of the people I loved were going to die. I accepted it, but it robbed me of joy, to say the least. I was taught that there was still one hope, that the world was getting better. Science was advancing, culture was advancing, even mankind was getting better. Through our efforts, we could make the world a better place. Through evolution, we could evolve into something better. Through progress, we might eventually defeat death itself. Perhaps we might someday even reverse degeneration of the universe. My personal hope was that I might in some small way contribute to such progress. I believe that this basic hope was shared to a large extent by my entire generation. One of my reviewers told me that the message of this book, that is Genetic Entropy, is both terrifying and depressing. He suggested that perhaps I'm a little like a sadistic steward on board the Titanic, gleefully spreading the news that the ship is sinking. But that is not correct. I hate the consequences of entropy, degeneration. I hate to see it in my own body, in the failing health of loved ones, or in the deformity of a newborn baby. I find it all absolutely ghastly, but also absolutely undeniable. Surely a real steward on the Titanic would have a responsibility to let people know that the ship was sinking, even if some people might hate him for it. I feel I am in that position. Responsible people should be grateful to know the bad news so that they can constructively respond to it. If we have been putting all our hope in a sinking ship, would it not be expedient to recognize this and abandon the false hope? It is only in this light that we can appreciate the bad news. Only in the light of the bad news can we really appreciate the good news, that there is a lifeboat. Even as we cannot create life, we cannot defeat death. Yet I assert there is one who did create life and who designed the genome. I do not know how he did it, but somehow he surely made the hardware, and he surely must have written the original software. He is called the author of life. I believe the author of life has the power to defeat death and degeneration. I believe this is the good news. It is my personal belief that Jesus is our hope. I believe that apart from him, there is no hope. He gave us life in the first place, so he can give us new life today. He made heaven and earth in the first place, so he can make a new heaven and earth in the future. Because he rose from the dead, we can be raised from death, even the death which is already enveloping us. In these profound yet simple truths, I believe there is a true hope. I believe this hope is unshakable because I believe it is founded on the one who is eternal. It is a hope that has withstood the attacks of time and the corruption of religion. It is a hope freely available to anyone who would receive it today. I humbly put before you this alternative paradigm for your consideration. Jesus is our one true hope. And with those words by Dr. Sanford, I conclude my presentation today. Thank you.
Thank you very much, Sal. That was great.
That was great. And that was a nice way to finish by reading that.
And that was written by John Sanford.
Yes, this book,
Yeah.
and that was a quote. I quoted the epilogue here. It's
That was
beautiful
really
epilogue.
good.
It's
Yeah.
a beautiful epilogue. The beginning of the book is great. The end is great. The middle is,
Long and tedious.
yes, it's written like a Cornell geneticist, scientist, but the spiritual significance is at the beginning, at the end. All the in between it's an arduous journey. But I read that when I was struggling with young Earth creationism. I was an old Earth creationist, and that was part of my journey from old Earth creationism to young Earth creationism.
Awesome.
And he
Thank you.
had a similar journey, by the way. He was Christian, then theistic evolutionist, old Earth creationist, then young Earth creationist.
Who's that astronomer that is the long age? What's his name?
Hugh Ross.
Hugh Ross. Yes.
Yes.
Okay. Terry was able to join us, so she's going to handle Q&A.
All right. So we have some questions that we're going to do while we're still recording and live streaming. And then I think we have a couple of questions we'd like to ask you after we turn off the cameras too. So if you'll stay back, but let's start with this one from Bill. So Bill has a couple of questions that he hopes make sense. The first one is, should, or in your opinion, should or could genetic testing be required before marriage in order to minimize mutations in the coming generations? I think he's basing it on our Christian fundamental hope that babies come only in marriage.
I wish I could answer that. That is a great question. By the way, Terry, thank you. I'm glad you're able to join us.
Yeah.
And I think you're going to get a variety of responses on that. And, honestly, that's something I feel unqualified to comment on. I mean, I certainly have my own belief. I think personally, we should be concerned about our birth defects. And, it says in the Bible, true religion is to care for widows and orphans in their distress. There is an opportunity to be of service and to have a family and to have kids and also fulfill that commandment. So I would just say, if the Lord leads someone to that conclusion, God is giving you other opportunities. I will say in the case of my family, the doctors were giving my mother birth control because they thought pregnancy was very dangerous to her, and it was. She nearly lost 2 babies. The third world doctors encouraged her to abort them. She said, no, I'd rather die. The daughters were born. They're my sisters. They went on to be nurses, and then there was me. As an aside, she had hyperemesis. They wanted to treat it with thalidomide. By God's grace, my mom didn't have that.
Praise God.
I could have been born without limbs.
Yes.
I know that that was a great question, Bill. So that's my best attempt at it. Thank you.
So what you're saying is that God is sovereign even over mutations.
Oh, yes. Yeah.
Also, Bill says, are recessive genes factored into all those complex calculus equations?
It depends on which model. I gave the simplest model, and it doesn't matter how you eliminate things. So in a word, yes. So remember when we were eliminating all the worst ones? Okay. So in a sense, let's just say all the recessive genes are doing their thing and, they're not reproducing. Well, even, let's say a family has 10 kids, but they're all defective. The recessive mutations may kill off 9 of them, but the one remaining still has birth defects. So in a simple word, yes. And we have done simulations, mathematical, that have shown even when we give generous assumptions of how recessive mutations, and all that, it would still fail. But the bottom line is we're observing it in the human population today. Now that we have gene sequencing, we're being horrified. I talked to these researchers and they said, we don't know how we're having, early onset of juvenile cancer and, this increase of autism, and it's getting bad. We as human beings have an expiration date. We're finding out civilization also does. It's written in our genome.
Well, I went to a panel discussion one time where Dr. Sanford was, and somebody asked him, how long do you think that the human race has? So what would you answer to that?
I don't have an answer. I will cite the evolutionary biologists themselves. They don't give us outside of 200,000 years. Well, that's a lot of time, but in their geological time frame, that's just the blink of an eye. But we have to be more concerned about the quality of life. Our IQs are declining. There is an abundance of just health issues. This is going to be serious. And, it says in the Bible, we're in the last days, and we don't, we're certainly 2,000 years closer to the Lord's return. I asked atheists even, how long do you think we have? They said, well, before our genome goes, I think human civilization will figure out how to annihilate ourselves with nuclear war nuclear, biological, chemical weapons and harm to the environment. And I'm just like, how long do you think? He said 500 years. I said, so even you atheists are saying it now. There's like no optimism. There's just this nihilism. Let us eat, drink, for tomorrow we die. It's, they quietly, I asked the people in the know, they said, yeah, we're kind of skeptical. I also think, Russell, I'll tell you Wikipedia, because I'm working, I gave a biology presentation today. My other interest is in physics. I've talked to Russell Humphreys. We're looking at geomagnetism. And I said, Russ, even Wikipedia says our geomagnetic field is going to be gone in 1600 years. That means the atmosphere is going to slowly sputter away. I mean, there any lines of evidence of how we're going to just be gone? And I've been saying, guys, we ought to be on our knees praying for God's mercy. I hope maybe we'll have a respite like in the times of Josiah. So short answer, I don't think much more than 200,000 years.
Okay, I think that's a pretty generous time frame. But we've had Alex Newman on before to talk about transhumanism, and I would say that that's probably the atheists' answer to this, is that they're trying to build ways that we can keep on going without genetics, and in that way play God. So that's one of the things that we've kept our eyes on too. So next question. For the evolutionists that are sticking with their hypothesis, but agree that the genome is deteriorating, when do they estimate the inflection point occurred, the change from improving to weakening, and to what do they attribute the cause?
I don't think as best as I've read it, I don't think they've been able to come up with any solutions. They have been trying to say that, 90% of the human genome is non-functional, because the more working parts you had, the more things that can go wrong. Just like when you type a long password, if you have a really long password, it's like, oh boy, I hope I get every letter right. And so basically the idea of a genome that has a lot of functionality, where you need a lot of essential parts, or they're very useful at the very least, even if they're not immediately essential, then more can go wrong. So they've been on a false assumption for a long time. And I think now they're having to come to terms like, how do we deal with this? So I've read the literature. They're just kind of closing their eyes and hoping someone else solves it. So to answer the question, when was the inflection point? I don't think they know. They had assumed that it was never an inflection point. They had said, well, modern technology is the cause of the current genome decay, because like a kid that has juvenile diabetes, now he can be given artificial insulin, and then he reproduces and, puts kids at risk that also inherit what he has. I had a friend, sadly, who had that, was in that situation. So they're blaming it on modern technology. So I'd say the inflection point is when we started to industrialize. So the idea is like, well, all these kids are living now. So I would say that would be it. But you could see that I had the highlight of that quote by Kondrashov. He said, why haven't we died 100 times over? So even independent of the Industrial Revolution and modern medicine and hygiene, the question remained. So some people, it's an easy scapegoat that it's modern technology. And so that's kind of the current mantra. But the ones who are really in the know that still only solves part of the problem.
Okay, so we have a comment on Facebook, and it goes to Bill's first question about genetic testing before reproducing. And it might be more of a comment, but maybe you want to also comment on it. But he says, isn't it the case that cells have the ability to fix mutations, such that if one spouse has in some place and the other doesn't, then when they're combined, it can be removed? Thus, near relatives shouldn't reproduce because they'd be expected to have the same mutations, which then can't be corrected by that mechanism.
It depends. It is true that what'll happen is let's say, we have pairs of chromosomes, and you'll inherit a gene from one of those pairs. If you happen to be lucky, you inherit the good version and not the bad, but it's a it's a run of the draw. It's a roll of the dice whether you're going to inherit it. And there was one case that I saw where a husband and wife, the father had a very horrific disease that caused his death, and his name escapes me. And they had to make that decision, and they were very grateful. The girl had a 50% chance of inheriting it, and she didn't get it. So there's some subtleties to all this. We won't have to go into it. It doesn't actually repair. You're just lucky to get the right copy. So you may have a good copy and a bad copy, and sometimes the parent will pass on to you the good copy. There are repair mechanisms in DNA, but that's in what they call the somatic cells, the cells that aren't inherited in the germline that ends up being, the kids. So like the cells in your own body, they can do a little bit of DNA repair, but it can repair it if it breaks, for example, but it doesn't correct a copy error very well. It does a little bit, but usually not enough. And now we're getting into really technical details. So, I appreciate the comment and the question, and, just so people know, I don't have kids of my own. God called me to take care of my mother. I did want to get married 18 years ago, and it just, God called me elsewhere, and I was where I needed to be. So maybe if you all figure it out, you could tell us.
Okay. Another question from Zoom. Can they point to any species on the planet that has a non-deteriorating genome?
I think bacterias are able to improve their genome they have the ability to take parts from other bacteria. So like this is how a lot of antibiotic resistance is developed. I mentioned it, you either develop antibiotic resistance by destroying yourself, or you borrow parts, plasmid transfer, horizontal gene transfer from others. So in a sense, yes, you can improve it. But I will argue that the general trend, for the reasons I stated in the discussion, is downward. And it's very simple. And you look at any complex device, you can't just take a screwdriver or hammer and start randomly changing your computer and expecting it to work. These things are so delicately.
Sal, I think we lost you. Sal,
I'm here.
did we lose him, Terry?
No, he's still here. We lost him for a bit, but his
Okay.
system recovered. So okay. So you were saying about the delicate. That's
It's
where you stop. Delicate.
Yes, it's very fragile. And I did see a warning. It said my internet connection is unstable. I'm just looking at my router down here. So you asked if there's any species. I would say there probably is. And I will tell you that one guy who just really has it in for Dr. Sanford is Daniel Stern Cardinal. Now, he and I actually have a good working relationship. Doesn't like John Sanford, but he and I can talk. And I said, Dan, anytime you want to talk. Now, he was the one who agreed with me that, all proteins do not have a common ancestor. Looks like an orchard. He said viruses aren't subject to this. And he's trying to cite all these viruses that are just multiplying. And that's been a long argument. So I would say, focus on the human. Once you start to talk about all species on the planet, God has made so many creatures and so many viruses. I don't think anyone on the planet would be able to answer that for sure.
I think she might be trying to go down the road that the earth is wearing out like a garment and that we are winding down. And if there was something that was not really winding down, I don't know, it could be suspect or something like that, but viruses are not a good thing.
Yeah. I will say this. One way that you can kill the genome is to kill the entire species. We are in the middle of what even evolutionists call the Great Extinction, the sixth Great Extinction. So if you just kill the entire organism, their genome goes too. You don't have to degrade it bit by bit like genetic entropy. And I actually talked to John about that, Dr. Sanford, I said, John, why don't we include extinction? He said, no, I like my version where it self-destructs. I said, no, I kind of like the version where it could either self-destruct or something else. An asteroid comes along and wipes it out. I think that's also genetic deterioration. He said, nah, I like my version better. So, but I mean, on a more serious note, we're losing so many bird species. We're losing all these. Anyone that's keeping track of how many creatures are being just lost totally. So what the evolutionists do is like an addicted gambler. They'll only like focus on everything that they've won. They forget all the big losses, and they built this beautiful model that's on cherry picked data. So it looks like they are finding, exceptions to the rule, but the problem is the rule is general decline, and there is a lot of extinction. And so you don't even need the self-destruct mechanism of genetic entropy. You could have external factors like what we're having now. And I think that's actually wiping out genomes even faster.
Okay, I have a question, and I've been wanting, like, I was hoping, I've tried several ways to get Dr. Sanford because I've had this question that I've been wanting answered for a couple of years. I'd like to know what's the difference between natural age, and then the curse-induced genetic entropy. Like, so for example, Adam was created with age. We know that he was older. I mean, obviously there's growth. I mean, when we age, we grow, right? But if it wasn't for the curse and genetic entropy, would older people have white hair? Would liver spots, things like that? Like, what kinds of signs of age would we see if it wasn't for the curse? Does that make sense?
Yes. First off, if it makes you feel any better, even when I worked for him, I'd be calling him, and sometimes I wouldn't hear from him for weeks. He's very focused on whatever he does.
Well, I was excited to hear that we could have you instead. Well, that's great. So thanks.
Not as good as having the real thing with Dr. Sanford, but I'm glad to honor his work as best as I can. He's just that sort of person. He's just very focused on, he loves people, but he can get worn out even speaking like I have today. This would totally wear him out because, his batteries are charged by studying things. He's just like a sponge, So as far as what we know for humans and also what we've observed, a big question in evolutionary biology is, why do we age? Because it seems like it would be very advantageous if you don't die, you can perpetuate and you don't have to go through all the growing pains again. It seems more efficient to just be alive. So what little we can glean from what little we have today, even, and then just a little bit in the Bible, because it doesn't really answer the question directly. If we accept and by the way, that was a big stumbling block for me as a teenager. People were saying, oh, there's no way that people live 900 years. And I found out, okay, there's this disease called early aging. It's progeria. It's caused, our genome is 3.3 gigabases, base pair, pieces of DNA. A few pieces get knocked out in a gene called nuclear lamin A. Say 3 or 4 of these are just compromised, you get early aging. That's all it takes. So if we reverse that, it could be just a few changes here or there, and we would be living long. And one of the evidences of eternal life is the Hydra. Scientists are perplexed about this thing called the Hydra. It's immortal. As long as it's fed and it's not killed, it lives forever. It doesn't have like a clock that will cause it to just self-destruct. And they're like, how's that work? We also have these things called immortalized cell lines. One of the first, if not the first that we found, was from a cancer patient, Henrietta Lacks, in the 1950s. She had ovarian cancer. They took cells, as part of the biopsy, and they realized that the cells had the unusual quality of just perpetuating. They're immortal, and like they just won't die. So extrapolating a little bit, it would seem that a lot of the capacity to self-repair has been switched off. And we know, if we accept that came with a curse, it's just been switched off. What would happen if it got switched on? We do see creatures that are able to regenerate limbs. Isn't that amazing? Did we actually have these capacities to regenerate injury? So all these things about spots and all. And then not to mention, if you're right with God, Jesus showed all he has to do is speak it. So a man with a withered hand, he said, healed him on the Sabbath day. So even if left to its own devices, something may fail. I would presume in the Garden of Eden, God would fix everything and make sure it's, that you wouldn't deteriorate. So it would be divinely protected on top of the fact that it probably already had a lot of natural properties.
Okay, that was a good answer. That was a thorough answer. So thank you for that. And thank you so much for being here. And would you like to tell people how they can find you, like read some of your work, or if there's a way to support your ministry, or how can people learn more?
Oh, wow.
You missed it, Terry. His book is $819.
Oh, I didn't miss it. I saw that,
Okay.
but sure. But I know that he has a website, right? You have a website,
Right.
Evidence and Reasons. And so I've been pointing people to that, but I'd like you to share that and if
Right.
there's anything else.
Okay, regarding the $819 book, I said, if you buy it, I don't get a dime. It's the publishers. They gave us certain privileges. They said, well, look at all the reputational perks you get by being published with us, but we're not going to pay you a dime. Seriously. So don't buy the book on our sake. What you got here today, you got for free, and you probably got it better here because it's not, in all the technical jargon, this is kind of made accessible. We weren't trying to impress the editors today like we had to do in that one. So evidenceandreasons.org is a good site. But if you Google Evidence and Reasons YouTube channel, you should find it. Now, I will warn you, that is actually an editing room floor. It is not finished products. I'm in the middle of trying to kind of make products like books to sell and teach educational courses. But there, if you want to donate to PayPal, there's a PayPal link in some of those videos. Now, that being said, I wouldn't even recommend my own channel that much to watch frequently because that's the editing room floor. There are some things in the works to try to have something more polished and published. And I'm going to be visiting Dr. Sanford this February, and hopefully I'll even see Diane and the gang at the Wonder Center along the way. We're trying to update his original book, Genetic Entropy. And so just keep your eyes out for that. He and I I'll be the lead author on that. He may give a foreword or be listed as a co-author. So I tell you what, the way you could support me is to pray. Pray that God will work the miracles I need to be able to be self-supporting in this. It's a tough environment right now. My former employer, they are requiring LGBTQ pronouns and all in vaccines. I mean, I'm not against vaccination. I've had thousands of them, but this whole COVID thing has bothered me.
Oh, we can't talk about that.
Oh,
We're recording.
sorry.
YouTube doesn't let, well, they that's okay. I should have told you at the beginning. So just, we get what you're saying. And as soon as we stop live stream, you can say what you want.
All right. But I can't return to a lot of Christians are not able to return to the workplace. So I've been taking odd jobs, including delivery, driving of food. I thankfully I've inherited a very nice property. I'm trying to be a landlord for that. So your prayers are probably the most important because it's our Lord and Savior that is the provider. I thank you for anyone that's interested in supporting my work, but your prayers are coveted. That's what really counts. And this work can move forward. So thank you very much. But if you're at all remotely curious, you can go to my that YouTube channel. You'll be bored to tears because then sometimes I get into the real technical details and they're long-winded. They're not polished presentations like today, but thank you.
Well, thank you. Thank you for joining us. And we appreciate that. And we will be praying for you. And then we also want to let people know that we're Creation Fellowship Santee, and you can find links to most of our videos by going to tinyurl.com/creation CF Santee. That's C like creation, F like fellowship, and Santee is spelled Santee. And you'll also find a list of our upcoming speakers, including links to their individual ministries. You can also email us at creationfellowshipsantee@gmail.com so you get on our mailing list and you don't miss any of our upcoming speakers. So with that, we're going to go ahead and sign off, go off the air. We have a couple of questions for you in the Zoom room. So
Thank you.